Hey gang, it's time for TEK 7 and 8. So I actually started the video on this one. You can see some of my answers down here, but I had to stop it. So I'm just going to pick this back up. So this is TEK 7 and 8. This is our quadratic equations area. Also, we had line of best fit, completing the square, factoring, a whole bunch of different things on quadratics. So I'm going to look at this first one, and I know I circled A, so just pretend like I didn't. So a quadratic function f has x-intercepts of 5 and -6. Which of the following statements about this function is false? Okay, so here's what I'm going to do. If I've got x-intercepts of 5 and -6, I'm going to go on my board here, and I'm going to actually draw them in. So x-intercepts of 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, -6 right here. So here's what I know. If I have a quadratics, and I have no idea what it looks like, so I'm just going to pretend like it looks like this. If this is my quadratic, and I go through -6 and 5, I know that these are my zeros, my solutions, my x-intercepts, my roots, whatever I want to call them, that's what those are. But I also could factor it. Remember factors when we say x times x, and then we take the x's and we plug them in, but we remember that those x's, they're sneaky tricky, and so they lie. They say they're +5, but they're really -5. They say they're -6, but I know they lie, and so they're going to be +6. So if I were to factor this quadratic, and again, I'm not sure what it looks like, I would do the opposite of it, right? It would lie. So that's what I know. So here's what I'm going to do. When I look at this and I read it, I'm looking for the function to be false. Which of these statements is false? Okay. So here's what I'm going to zoom in a little bit, see if I can get all that in my screen. I can. The factored form of the equation is y equals x minus 6 and x plus 5. No, I know the factored form is that it lies. So that's actually false. But I'm going to read the others to be sure. The factored form of the equation is x plus 6, x minus 5. Yes, that's true. The standard form of the equation is x squared plus x minus 30. Ooh, let me check that. So let's check that. Is this the factored form? So remember to factor this, since I know this is the factored, and I want to actually not factor, I said that backwards. I want to look at the standard form. I'm going to take this, and I'm going to put x in -5 and x in +6. X times x is x squared. X times -5 is -5x. X times 6 would be 6x. And 6 times -5 would be -30. On the diagonal, I add them up. X squared plus 1x, 6 minus 5 is 1, and then minus 30. All right, so this is the factored form, or the multiplied out form. And that's what it is. So the standard form, yep, that's true. The zeros are at 5 and -6. Well, yes, that's my zeros, 5 and -6. So, yes, A was the incorrect because the factored form was -5 and +6. So that's where I got the A. All right, the next one. I started on this one, and this was when I got, somebody came in my room and I had to stop. All right, so here we go. Write an equation of the function g of x in vertex form. It is f of x, which is all that, translated 2 units up and 5 units to the left. So here's what I would do. I would take that maybe and put that in my calculator and look at it, or I would realize that this is vertex form. HK. HK is my vertex. X's lie, so I would bring out a +8. K is okay, so 10. So 8, 10 is my vertex. Here's what I'm going to do. I'm going to come over here, and I'm going to, on my board, I'm going to graph 8, 10. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's my vertex. The vertex is at 8, 10. Here's what it wants me to do. And it doesn't matter if my parabola goes up or down. That part doesn't matter. I know that this particular one is a happy graph because the A is +1, so it's a happy graph. If it was -1, it'd be a sad graph. I'm going to translate this up 2 units. So here's what I'm going to do. I'm going to go here and I'm going to go up 2. Oh, here's a black. I was looking for a different colored marker. I'm going to go up 2. So 1, 2. So I'm right here. From that point, I need to go 5 units left. So I'm going to go over 1, 2, 3, 4, 5. So I'm right here. So this is my new vertex. Same thing going on. That's my new vertex. So it wants me to write the equation in vertex form. Okay, so here's vertex form. A times x minus h squared plus k. Now, g of x, I'm going to go ahead and write what g of x was. G of x was x minus 8 squared plus 10. What's my new vertex right here? Well, let's see. It's 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my new vertex is at 3, 12. So the 8, I'm going to say, did they tell me what to call it? Write the equation function g of x. Oh, I'm sorry. This is an f. This is f of x. So my new function is g of x equals. It is x, and then I'm going to plug in my x value, minus 3. It's the opposite of what you say. So it's at positive 3, so I'm going to record it as negative 3. And then 12 up, so plus 12. There is my new g of x. Up 2, and it moved to the left 3. Left 3. All right. Okay, so that gets number 6. So let's keep going. Let's look at number 7. All right, number 7 says, between what two numbers would I find a positive 0 of this parabola? Between what two numbers would I find a negative solution? Okay, so let me get my pen, which was disappeared on me. Oh, there it is. Okay, so let's do a positive 0 of this parabola. So I'm going to write positive 0. Where would I find where would I find the zeros? Let me zoom in on that. Let's see. The zeros are right here and here because the zeros are the solutions, right? They're the x-intercepts. So between what two numbers? Between 1 and 2, I would find a positive 0. And between negative 1 and negative 2, I would find a negative 0. Okay, actually that's pretty easy. Not sure why that's on there. A positive 0 between 1 and 2. And then I'm going to say a negative solution between negative 1 and negative 2. This one would be negative, this one would be positive. Okay, I like that one. That was easy. The table represents a quadratic equation. Where's the vertex? Okay, so I'm going to look, and it looks like 130 is my vertex, doesn't it? Okay, don't put that. These are not going in order. It's skipping around. Here's what I'm going to do. I'm going to go to my calculator. I'm going to turn it on. I'm going to go to Stat, Edit. I am going to put this in my calculator, okay? So let's put this in, negative 2. Actually, I'm going to pause this while you put it in, and in about a second, it's going to be done. And voila, there it is. Okay, so I'm going to go back to Stat and calculate. I need to do a quadratic regression. So I'm going to do number 5. Enter, enter, enter. Right here, I'm going to do alpha y equals. And I'm going to scroll over, and I'm looking for that y1 so that it'll store it in there for me. I could probably just write it, but anyway. Okay, so there's my equation. So I'm going to come up here, and I'm going to actually write that. Y equals 2x squared minus 8x minus 24. Okay. I'm going to go to y equals, I'm actually going to clear that out, 2x squared minus 8x minus 24. Okay, I'm going to go to second and table, and I want to see my table. I'm just going to check. Negative 2, 0. Negative 1. Okay, so there it is. So let's see if we can find the doubles. All right, 18, 18, 0, 0, negative 14, negative 14. It's honing in on 2, negative 32. All right, so what's my vertex? It is at 2, negative 32. The axis of symmetry has an x in it, which means it's x equals. What is my x value of my vertex? It is 2. The y-intercept, where does it go through the y-axis? Okay, hold on. All right, guys, sorry about that. So we did the axis of symmetry. So the y-intercept, where does it cross the y-axis? So I'm going to actually just graph it, and maybe I can see it, but if I can't, I can see that it's down here. So it's down low. So I'm going to go to second table, and I'm going to look. When x is 0, where is the y? It's at negative 24. So that means my y-intercept is at negative 24, or you could put 0, negative 24. The x-intercepts, where are they? You can see I've got one at negative 2 and one at 6. So they're at 6 and negative 2. All right, so let's take a look at number 9 now. So which of the following represents the solution to the quadratic equation this? If I look at these, I notice that they are all in radical form, right? So what I want to do is graph this, and I think I'm going to use Desmos to graph this. I'm going to grab my phone and get my Desmos out on it. And from there, I'm going to graph it. So let me see if I can do that. Yep. So I'm going to do x squared plus 4x, and then plus 1. All right, so I'm going to touch on my zeros, and I can see they are at negative 3.732 and negative 0.268. Okay, so I just need to figure out which one of those matches that. So here's what I'm going to do. Now, I could have used my quadratic equation, but since this is multiple choice, I think I'm going to not do that. So I'm going to do negative 2, and I'm going to do plus second square root of 5. All right, so this one is 0.236. Okay, it's close, but it doesn't match. I'm going to put what it is right here, 0.236. I'm just going to do one of them. If one of them works, then I'll do the other. 2 plus second square roots of 3. I'm doing C right now. I'm going across. Oh, look at that. Oh, but it's positive, and I need a negative. So this was 3.732. Let's do B. Negative 2 plus second square root of 3. Oh, here we go. Negative 0.267. So here we go. That looks like that, doesn't it? Yeah, because they just rounded up. So I'm going to do this same one, but I'm going to do the minus one. So negative 2 minus second square roots of 3. And it's negative 3.732. Looky there. So this one had both of them in it. All right. Number 10. Given the following quadratic equations, so they're giving me all of these, do they have the same y-intercept? Okay, so I'm going to go back to Desmos, and I'm going to plug this in. I'm going to say f of x. You know what? I don't really think I need to put f of x. I'm just going to put x squared. I'm going to be lazy. Negative. Negative x squared plus 64. And then I'm going to do negative 2x squared minus 51. And I'm going to do x squared plus 14. All right, so I'm going to zoom out just a little bit so I can see all of them on the same screen. There they are. Okay, hopefully you can see those pretty well. Okay, so here's the question. Do they have the same y-intercept? Okay, no. Look at all the different y-intercepts. Yeah, they're all different. So no, they do not. I'm going to say no. Do they have the same axis of symmetry? Axis of symmetry is the line that goes in the middle of them. They all are on the y-axis, the vertex is. So therefore, the axis of symmetry is the same. So yes, What is the axis of symmetry? Axis has the letter X in it, so it's X equals, what is it? On these, they all are right here at 0. They're all at 0. Do they have the same vertex? Definitely not. There's that vertex. There's that vertex. So definitely no. That's a big no. Do they have a max or minimum vertex? Okay, let's do this. I'm going to touch these and turn those off. Let's look at the first one. Negative x squared. Oh, sorry. I was moving my phone instead of that. Would that be a maximum or a minimum vertex? That would be a maximum, right? Because it's the tallest. So on this one, I'm going to say maximum vertex. On the next one, so I'm going to turn that off and turn that one on. There it is. So let's find it. Is it up here? Nope, it's down here. There it is. That would be a maximum vertex. And now let's look at the last one. So I'm going to turn that one off and turn it on. And there it is. It's at the bottom. So it would be a minimum vertex. Okay. Now, what are the zeros of the quadratic equation? So here we go. So let me X these out from a while ago. Let's put in 3x squared minus 7x plus 6. Okay. What are the zeros? So let me zoom in. Oh, there's the x-axis right there. Where are the zeros? There's not any. So I'm going to say there's none. All right. What are the zeros of the function? What are the zeros of this function? So we're going to put these in. And I'm running out of time, guys. I'm trying to make it to an ROTC banquet. And I may not have time to do all these. Minus 3x minus 10. I'm going to look at the zeros. You're going to write them down. It's 3.108 is one. And negative 1.608 is the other. You want to convert those in, do math, enter, and turn those into decimals or into fractions. Oh my goodness. I can't do that. 1.08. Let's see if it works. Yeah, so it's not going to work on that one, so we're going to leave them as decimals for now. All right, what is the solution to this one? This one doesn't equal 0, so we need to make it equal 0. So 5x squared minus 14x. I'm going to move the 3 to the other side, so that's going to become a negative 3 equals 0. I'm going to plug it into Desmos and see what I can get. So I'm going to have 5x squared minus 14x minus 3, 0.472, and I've also got 1.272. Oh my goodness. I messed it up. 0.4. I was looking to see if I could convert it into a decimal or into a fraction. Boy, I keep saying that. Yeah, no, it's not going to let me. So anyway, so I'm going to go with those on both of those. I believe those might have been quadratic equation ones. All right, that completes 7 and 8. Thanks for watching.